السلام عليكم ورحمة الله. Um, Welcome, my dear students. In this recording, we will be finishing the rest of Module 5. So for both of the sections I'm teaching, one of the sections have already covered nested loops and also covered the continue and break statements. And one of the sections did not reach the continue and break statement. So I'm going all over again, explaining from the idea of nested loops, just to make sure that everyone have gotten the idea correctly, and I'll go over everything else. If you happen to understand the first part of this lecture, then you can skip to the part where you need to really understand. If you have any question later on, you can send me an email, and inshallah I will respond as soon as I see your email. Okay, so let's start. We've talked about nested loops during the lecture, and we've said that nested loops is just one loop inside another loop. In this example here, we have two loops, and as I said, I always like to mark the start or the beginning of the first loop and also mark the beginning of the second loop. This helps me trace when the loop starts and when the loop ends. So the while loop is the first loop, which is the outer loop, and inside the outer loop there is two statements. This is the first statement. I'm going to highlight it in let's highlight it in blue. So I'm going to highlight it in blue, and there is also a statement here which belongs to the outer loop. Why did I say this belongs to the outer loop? Because look, this is where is the pointer? So this is exactly the curly bracket that closes the insider loop. So here the inside loop ends. So this statement over here belongs to the outer loop, and here the outer loop ends. Okay, so it's not necessary to put all the statement for the outer loop above the inner loop. No, it can look like this. Okay, for the inner loop, this is the inner loop. It's highlighted in green. So this is the inner loop. I think everything looks clear now. Let's go over the code. So the code defines three variables: week, which is equal to 3, and we have days, which is equal to 7, and we have I, which is equal to 1. Let's go start the loop. So while I is less than or equal to weeks, now the value of I is 1 and the value of weeks is 3. Is 1 less than or equal to 3? Yes, it is. So since the condition is true, I'm going to start executing the statement of the outer loop. The first statement says system.out.print line week. So I want to print this the text that says let's start from here. The text that says week, and then colon, and then there is a space here. So a space here, and then plus I. The plus I here refers that you want to do a concatenating. What's a concatenating? You want to print a text and put a value of an integer or a number next to that text. If you want to print a text and stick a value of integer or int next to that text or that string, then you are going to use the plus sign. So here I'm just printing the value of I, which is 1. Done. Now we're going to start the inner loop. In the inner loop, we have defined int I equal, j, it's equal to I. And as I said during the lecture, it's always wise to have a different control variable for the outer loop and a different one for the inside loop. So you don't get confused and the Java don't get confused. So the outer loop, the control variable is I, and the inside loop, the control variable is j. So j is equal to 1. And then we're starting to ask this question. As long as j, which is 1, is less or equal than the value of days, which is here 7, then we're going to start the loop. What does the loop say? It says system.out.println. So the print line here means that we are going to print the line, and then the cursor or the cursor of the printing in the console will go to the next line. So it's going to add a new line. So we're printing the first statement, and then we're going to start from the new line. So here we're leaving a space, so a space, and then printing days, and then a colon, plus, and another space here, a plus j, which means we want to print the value of j. The value of j is now 1. We're going to go back. We did not finish the inner loop, so we're going to go back to execute the inner loop again. The first thing that will happen is the increment of j. So this means that the value of j will be increased by 1. So j is now 2. Let's test the condition again. Is 2 less than or equal to 7? Yes, it is. Then I'm going to do the printing. System.out.println, we're going to leave a space, then days, a colon, a space, and the value of j, which is now 2. Again in the loop, the value of j is now 3. Is it 3 less than or equal to 7? Yes, it is. Then I'm going to leave a space because there is a space here, and then printing days, colon, and then a space, and then the value of j. So this will continue until what? Let's say until the value of 7. Is 7 equal or less to 7? Yes, it is equal. So I'm going also to print days, colon, and the value of 7. Now we're going to go again in the loop. 7 will be 8. Is the value of 8 equal or less to 7? No, it's not. Then the inner loop will stop. When the inner loop stops, I'm first going to look, is there any remaining statement from the outer loop? Yes, there is a remaining statement. Where is the remaining statement? Is this one. So it says plus I. Then where is the I? Here is my I. I will be increased by 1. So instead of having I1, it's going to be 2. Now I'm going to start the outer loop all over again. So the outer loop, we're going to start all over again. And the first thing I'm going to do is asking, is the value of I, which is now 2, less than or equal to the value of weeks, which is still 3? Yes, it is. Then I'm going to print this statement, which is week, and the week, the value of I is 2. So week number 2. And going to jump to the inner loop. In the inner loop, we start the loop all over again. What does all over again means? It means that I'm going to define j again. So j will going to be defined all over again. The value of j now is 1, and I'm going to ask, is 1 is less or equal to the value of days, which is 7? Yes, it is. Since the condition is true, I'm going to print days and the value of j. So let's print space, days, colon, and the value of j, which is now 1. Increasing the j by 1. J is now 2. Then printing days, the value of days is 2. Again, increasing the value of j to 3. Days value of j is 3. Again, all over until the last statement that will be printed here is days 7. We are going to stop when j is 8, but the 8 will not be printed. Why? Because when we are asking is 8, which is the value of j, less than or equal to 7, the condition will be false. If it's false, then the inner loop will stop and I will jump to complete the statement of the outer loop. There is one statement here, which is the increment of I. So I'm going to increase the value of I by 3 and go all over again to the outer loop. Now let's ask, is the value of 3 in this statement here, is the value of 3, which is I, less than or equal to the value of weeks, which is 3? Yes, it's equal. Then I'm going to print this statement here, which is week and space and then 3. Okay, and then what's going to happen? I'm going to start all over again in the inner loop. Let's go in the inner loop. This is the inner loop. So in the inner loop, I will go all over again and define the value of j. I'm going to start the loop again from the first value of j. So 4, I will define j again, and I'm going to make the value of j 1. And now I'm testing the condition. Is 1 less than or equal to the value of days, which is 7? Yes, it is. So I'm going to print days 1 and go over the loop again until I print the value of days 7. When j is 8, the condition will be false and this loop will stop. I have one statement left from the outer loop, which is the increment of I. So I now is going to be 4. I will go back to the outer loop. The outer loop I will ask, is 4 less than or equal to the value of x, which is 3? No. The condition is now false, so I will not go again inside the outer loop, which means I'm not going back again to the inner loop, which means I have stopped my program. So you start with the outer loop, a loop inside the inner loop until the value is false, and then you go back to the outer loop. You keep doing this until the outer loop is false. When the outer loop is false, you stop. You stop the nested loop. Okay, so I hope this is clear. Let's go into this example over here. We'll go through it very quickly. So the outer loop is 4 and the inner loop is another 4. The outer loop starts from here and ends here, and the inner loop starts from here and ends here. And also we have one remaining statement here that belongs to the outer loop. How do I know that? I know that because here the inner loop starts and here it ends. So of course this statement over here remains belongs to the outer loop. The outer loop starts from this parenthesis and end in this parenthesis. So this one belongs to the outer loop. In this program, we defined the value of rows. Rows is 5. So rows is equal to 5. And we start the outer loop for until I is equal to 1. So I is 1. I'm going to ask a question. Is 1 less than or equal to the rows, which is 5? Yes, it is. 1 is less than or equal to 5. Then there are no statements here in the outer loop. This is just a comment, and the comment is not executed by the compiler, just for you. So we're going to start the inner loop. For int j, we define j, and the value of j is 1. Here there is a condition. The condition says, let's write the condition here. As long as the value of j, which is 1, is less than or equal to the value of I, which is also 1, I'm going to execute the statement of the inner loop. What are the statement? System.out.print, print the value of j. I'm going to print the value of j, which is now 1, plus a space. So I'm printing a space just behind this value. So going back again into the loop, increasing the value of j by 1, it's now 2. Let's go and ask this question over here. The condition says, as long as the value of j, which is now 2, is less or equal to I, which is 1, the condition is now false. So the inner loop will stop, and there is also one statement here from the outer loop which will be executed. It just means system.out.print line. I just want you to print an empty line here. Empty line here, which means that next time I will print, I will go into this new line over here. Not doing the printing in the same line. No, I want to go into another line, a new line. So this is the whole point of this new of this printing statement that's over here. Let's go back. So when I go back, now the value of I will increase by 1, and then I'm going to start all over again in the 4. The 4, which means that the value of j, the inner loop, the inner 4, the value of j will start all over from 1. Now we're asking, again, is the value of j, which is 1, less than or equal, sorry, this is 2, to the value of I, which is 2? Yes, it is. Then I'm going to print j, which is 1, and then a space. Go back again, increase the value of j by 1. So j is now 2. Is 2 less than or equal to 2? Yes, it is. So since the condition is true, then I'm going to do the printing. I'm printing next to it. I'm printing the value of j, which is 2, and then leaving a space. Increasing the j by 1. Now it's 3. Is the value of 3 less than or equal to 2? No. Then this will stop the inner loop, and I will print a new line. Print a new empty line, and go all over again to the outer loop, which increases the value of I by 1. So I is now 3. And you are going to start all over the inner loop from the beginning, which is from j1. Now, let's go back and ask this question, or check the condition. Is j, which is now 1, less than or equal to the value of I, which is now 3? Yes, it is. Since it's true, I'm going to print 1 and then space. Again, increasing the value of 2. Of j by 1, which is 2. Is 2 less than or equal to 3? Yes, it is. Then I'm going to print 2 and then space. Increasing the value again by 1. Is 3 less than or equal to 3? Yes, it is. Then I'm going to print a 3 and then a space. Finished with the inner loop. Now I'm going to print a new line and go back to the outer loop. This will continue until you reach 1, 2, 3. This is going to be 1, 2, 3, 4, and this 4, 5. This is the last printing line. Why? Because the number of rows is 5. The last thing I will be printing when the number is 5. When I becomes 6, this means that the outer loop condition will be false, and I will no longer be able to execute the statement of the outer loop or the loop inside. Okay, so just trace the code exactly like I'm doing, and it's going to be easy peasy, inshallah. Now, let's go to another thing. We want to know what's the difference between the break statement and the continue statement, and why these are used. So, for the break, when executed in a while, when you have a break statement in a while, or a for, or a do while, so when you have it inside a loop or inside a switch statement, what's going to happen? It will cause an immediate exit from the statement. Once you see a break inside a loop or switch, then it will cause the loop to end, or the switch statement to end. So this is an immediate exit from that statement. The execution will continue with the first statement after the control statement. What does that supposed to mean? Look in this code. For starts here and ends here, and there is inside an if statement. If the condition is true, I'm going to break. What will happen here? If the break executed, then it will cause an immediate exit from the for loop, from the whole loop. So the control will transfer from here to the first statement after the loop. The loop starts here and ends here. The first statement after the loop is the sprinting statement. So the transfer will control here. This is what line says. Execution continue with the first statement after the control statement, which is this line over here. When do we use break? If we want to escape early from the loop, we want to stop the loop early at some point, then we use it. Or if I want to skip the reminder of a switch. When we talked about a switch statement in an earlier lecture, we said that when we use switch, we have usually here a variable. Let's say the variable is I. And the value of I, let's assume that the value of I is 1. Okay? Then we are switching over cases. Case 1 is 1. The first case is 1. The second case is 2, and we have the default over here. Okay, if the value of I is 1, it means that the first case will match and the first case will execute. Once the first case is executed, if there is no break statement here, it means that this will execute also and the default will execute also. So the remaining of the switch statement will be executed. However, if the first case has matched and is executed, but you have a break statement over here, it means that once the first case is executed, I'm going to execute the break. The break means I will go out the whole switch statement to the first line after the switch statement. And this was also explained in that lecture. Let's go over the example. So as I said, here we have this for loop, and it starts from here and ends here. When we start the program, we are defining a variable that's called count. The value of count is for count equal to 1, so 1. And then we're asking a question. Is the value of count, which is 1, less than or equal to the value of 10? Yes, it is. As long as it's true, then I'm going to start the loop. I've started the loop. The loop said, if count, which is now 1, equal to the value of 5, I will break. Is it equal to the value of 5? No. The condition is false. So I will not do this. I will go here and system.out.print. It means I will print the value of count. The value of count is now 1. Go back to the loop. I will increase the count by 1. It's now 2. Is 2 less than or equal to 10? Yes, it is. Now I'm going inside the loop. Is count, which is 2, equal to 5? No. Then I'm going to print the value of count, which is 2. Again, increasing the value of count by 1. It's 3. Is 3 less than or equal to 10? Yes. Okay, now we're asking, is 3 equal to 5? No. Then I'm printing the value of count, which is 3. Increasing count by 1, 4. Is 4 equal to 5? No, it's not. So I'm not doing the break, I'm doing this line, which is a printing of the value of 4. Again, we increased count by 1. Count is now 5. Is 5 less or equal to 10? Yes, it is. Is 5 equal to 5? Yes, it is. Since it's equal, then this line will be executed. What this line says, it says break. Break means I'm going to go out of the for loop. Where does the for loop ends? It ends here. So I'm going out from here to this statement over here. This statement says system.out.print. Print for me, first a new line. So I'm going down here, a line, then broke out of the loop at count. It will print the statement broke out of the loop at count, and the value of count is equal to what? This is the last value of count, is equal to 5. So this is how break is used. I want to end the loop early. I want to end the loop when the value of the count is equal to 5. If you want to end the loop when the value of count is equal to 3, you just change this value over here. Instead of 5, you will be writing 3, and so on. Okay, so that's for the break. For the continue statement, when executed in a while or a for or a do while, so when you have a continue inside a loop, what's going to happen? It will skip the remaining statement in the loop body. So it's not going to execute an immediate, do an immediate exit from the loop. No, it's going to do something else, which is skip. What does skip mean? It means it will ignore the rest of the statement in the loop and proceed with the next iteration and go back to start a new iteration of the loop. Okay, we will take an example now and understand. But we need to know a difference in the while and do while statement. The program evaluate the loop continuation test immediately after the continue. If I have a continue inside a while or do while, I'm going to start a new iteration after the continue. First, I will test the condition. If the condition is true, I will go inside the statement and do whatever statement is inside. However, in a for statement, if there is a continue inside the statement and you are starting a new iteration, first you are going to do the increment expression. So if there is a continue and you are going to go back to a new iteration, you are going to start here first, do the increment, and then test the condition. So this is one of the difference between having a continue inside a do while or inside the for loop. Let's go over it. So the loop starts from here and ends here. Okay. For the loop, we have defined a variable called count, and its value is equal to 1. As long as 1 is less than or equal to 10, I will start. When I started the loop, there is an if. Is the value of count equal to 5? No. So since it's no, then I'm not going to execute the continue. I will going to execute this line here, which is system.out.print, print for me the value of count, which is now 1. I'm going to loop all over again, increasing the value of count by 1. So it's going to be 2. Is 2 less than or equal to 10? Yes, it is. Is 2 equal to 5? No, then I'm not going to do this. I will go and do this line, which is printing the value of count, which is 2. Increasing count by 1. It's now 3. Okay. Is 3 less than or equal to 10? Yes, it is. Is 3 equal to 5? No, it's not. Then I'm just going to print the value of count, which is 3. Increasing to 4. And I will print 4. Let's see what happens when the value is 5. Is 5 less than or equal to 10? Yes. Is 5 equal to the value of 5? Yes, it is. Then in this case, I will go and execute the continue. What does the continue do? It doesn't. It does not cause an immediate exit of the loop. No, it just going to skip the remaining code in the loop and start a new iteration. So I will skip the remaining statement in the loop and proceed with the next iteration. So this is the remaining bit of the loop. I will just go and start a new iteration. Since this is for, what part I will start first? It says if it's in the for loop, then you go to the increment expression first, and then you evaluate the loop continuation test. So I will go here and increase the value of count by 1. Now count is 6, and then I will go and test the condition. As long as it's 6 less than or equal to 10, I'm going to go here and ask the question. If 6 equal to 5, no. Then I will do this, which is printing 6. Again, 7. This will be false, so printing 7 until printing the value of 10. Once the count is 11, the condition will be false, and I will not go inside the for loop anymore. Once the for loop has finished, I will print system.out.print used, so a new line first, and then used continue to skip printing number 5. So this is what's going to be printed, used continue to skip printing of 5. If you look at the sequence of the printed numbers, we printed from 1 to 10, and we skipped the value of 5 because we did not print it, because we used continue here. If you want to skip the printing of, let's say 3, then you are going to replace 5 with 3. If you want to skip printing the value of 9, you're going to have 9 here, and so on. So it just continue, skip the remaining or ignore the remaining statement of the loop, and start a new iteration again. I wish this is understandable. Okay, now we're going to go through the logical operator. We have understood the mathematical operator before, which is the plus, the minus, the division, and so on. This is not the only expressions that we have. We can also use the logical operators. They are very important when you want to make complex condition. What does complex conditions mean? We're going to see now. First, we have different types of logical operators. We have the conditional AND, which is double AND, conditional OR, which is this double line here, a Boolean logical AND, which is one AND symbol, a Boolean logical inclusive OR, which is one line over here, Boolean logical exclusive OR, which is this symbol over here, and the logical NOT, which is the symbol over here. All of them are called logical operators. Why? Because we use them to make a condition a little bit more complex. Let's go over all of them. The first one, which is the conditional AND. AND mean و. Okay, بالعربي يعني و. In the AND, we will have AND in the middle, and then we're going to have an expression here, the first one, and an expression here. This is the second one. So we will have two expressions, one on the right and one on the left. And the AND will be in the middle. It says, with the AND, if the first condition is false and the second condition is false, then the whole condition will going to be evaluated as false. So this is what we say is about making complex condition. And instead of having just only one condition, we're having now two conditions combined by this logical operator, which is one. For the whole condition to be true or false, we need to look at these individual subconditions over here. So the first one with AND, if the first one is false and the second one false, the whole condition will be evaluated to false. If the first one is false, the second is true, the whole thing will be false. If the first one is true, the second is false, the whole thing will be false. The only case with AND where the whole condition will be evaluated to true is when both sides are true. If this is true and this is true, then the whole expression will be evaluated as true. Let's have an example. To ensure at some point in a program that the two conditions are both true, we're going to use the logical AND operator. So let's imagine that we have gender, a gender variable, and we have an age variable. The gender is inside the gender variable is female, and inside the age variable is 80. Now we have this condition. In the middle here, we have and we have two operands, so two conditions. This is the first one, and this is the second one. Let's see. Is gender is gender equal to female? Yes. The gender has a value of female, so this is true. Now, is age greater than or equal to 65? Yes, it's 80, then this is true. Since this is true and this is true, from the table over here, I know that the whole condition will be evaluated to true, then this whole condition will be true, then this will be executed. Okay, let's think of another, for example, another example. So age here is 18. Okay, is gender equal to female? Yes, it is. So this is true. Now you're asking, is age greater than or equal to 65? No, age now is 18, so this is false. From this table, I know the first one is true and the second one is false. Everything will be false. So the whole condition will be evaluated as false, then this will no longer be executed because the condition is false. Easy peasy. The if statement condition is true. It's the only case where the whole if condition will be true is only if both conditions are true. If this is true and this is true, the whole condition will be true. And you have to put something in mind, which is with the double AND, so with the AND, this one, Java will stop evaluating if the first condition is false. So what is this supposed to mean? Let's imagine that the gender is not female. So the value inside of gender is male. Now I'm asking, is gender equal to female? No. This side is false now. If this side is false, then Java will stop evaluating if the first condition is false. Java doesn't need to look at the second condition at this case. Why? Because no matter if the second condition is true or false, at the end, all of this condition will be evaluated at false. So if the first one is false, so no matter what is the result of the second condition, whether it's false or whether it's true, in both cases, the whole condition will be false. So this will happen to save sometimes when you're executing a program, especially if the program is long and a little bit complicated, to save some of the runtime, this will happen. So with the double AND, once the first condition is false, Java doesn't need to look at the second condition anymore because the whole condition will be evaluated as false. Second operator is or يعني أو. With the or, if the first condition is false and the second is false, then the whole expression will be evaluated as false. The first one is false, second is true, then the whole thing will be true. First is true, second is false, whole thing is true. First true, second is true, whole thing is true. So with the or, you need at least to have one of the operand or one of the sides or one of the conditions to be true in order for the whole condition to be evaluated as true. So this is the example. To ensure that either or both, so one of the condition or both of the condition is going to be true before we choose a certain path of execution. Let's assume, so this is our operator, and this is the first condition over here, and this is the second condition over here. Let's assume that we have semester average, this variable, the value of this variable 80, for example, and the value of the final exam variable is also 80. Okay, so let's ask the question, if semester average bigger or equal than 90. Is it? It's now 80. 80 is not greater than 90. So the value here is going to be false. Is final exam, which is now 80, greater than or equal to 90? No. Then the condition is false. And from the table over here, we know if the first one is false and the second one is false, then the whole condition will be evaluated to false. So everything will be false at the end, and this will not be executed. Okay, let's go into another example. Let's imagine that the final exam, instead of being 80, it's 100. So the first semester is still 80. Is 80 greater than or equal to 90? No, it's false. Or is the final exam greater than or equal to 90? So the final exam value is now 100. Yes, 100 is greater than or equal to 90. Then this will evaluate to true. From our table, we know that if the first one is false and the second one is true, then the whole condition will be evaluated to true. So here, the whole condition will be evaluated to true, and this will execute. I will print student grade is A. And I have to put in mind this very important note. With the double or, so with the double line, which is the conditional or, if the first condition is true, Java skips evaluating the second one. So what's that supposed to mean? Let's say that the value of the first variable is 100. So the semester average variable equal to 100. So we're asking here, is the semester average, which is 100, greater than or equal to 90? Yes, it's true. In this case, the first condition is true. So Java doesn't need to look at this condition anymore. Why? Because whether this condition is true or false, the whole thing will be evaluated at true at the end. Let's see from here. If the first one is true, and doesn't matter if the second expression is false or true, because at the end, all of them are going to be true. So this is also done for speeding the execution of the programs. The second or the third one is a Boolean logical exclusive OR, which is the symbol over here, like a small triangle. This one is true if and only if one of its operand is true and the other is false. It's a little bit tricky. Let's see. If the first expression is false and we use the symbol and the second expression is false, then the whole thing will be evaluated to false. If the first one is true and the second is true, then the whole thing will be evaluated as false. But if the first one is false, the second one is true, the whole thing will be true. If the first one is true and the second is false, the whole thing will be true. So the only cases where the whole expression will be evaluated as true is if there is true at one of the operand. Once you have one of the operand is true and one of the operand is false, then the whole expression will be evaluated as true. Okay. The remaining three operands are the Boolean logical AND, but here it's just one simple, one AND the Boolean logical inclusive OR, which is just one line, not double like the slides before, no, just one line. So in concept, these operators are identical to these ones, but with a small difference, except that with the single operands, they are always evaluating both of either operands. What did I say here? I said in, for example, in this AND, the Java will evaluate the first, we're in the AND, evaluate the first condition. If the first condition is false, the Java doesn't need to look the second condition, because no matter if the second condition is true or false, the whole condition will be evaluated as false. This is with the double AND. However, here, no. With the single AND, the Java will always evaluate both of the condition. Whether the first one is true or false, it will always look at the second condition. So evaluate age is greater than or equal to 65, regardless of whether gender is equal to 1 or not. So this is useful sometimes if the right operand, which means this condition here, are required, has a required side effect. So with the single and Java will always evaluate both sides. Exactly with the single or, Java will always evaluate both sides, whether the first one is true or not. Okay, so thus the variable age here will be increment in both cases, and then I'm going to test this condition over here. So just the difference that in the double, sometimes in some cases I will need only to look at one operand, but with the singles one, I will always evaluate both sides or both operands, exactly as we explained. The last one is very easy, the logical operator, which is the simple over here. We always look we always say that this operator is called not. What does it do? It just reverses the meaning of the condition, or the it just reverses the meaning of the condition. So let's take an example. You are asking, is grade equal to centile value? Let's say that grade is 30 and the centile value is 30 as well. This is 30 and this is 30. Okay, so I'm asking question, is the value are equal? Yes, they are. So the result is true. But because we have this operand over here, we are reversing the meaning. And instead of being true, it will be evaluated as false because we're taking the reverse of it. So system.out.print will not be executed because the whole condition will be evaluated as false. It can be written like this, or can be written at this. If we're asking grade, does the value of grade doesn't equal to the value of centile value? Are they not equal? No, they are actually equal. So this will be evaluated as false. So this will not be executed. So you can use it as this, or you can use it this way. The not operator, or the exclamation mark, just giving you the reverse. If it's false, that is going to be true. If it's true, this is going to be false. That's it, easy peasy. Here are the precedence and the associativity of all the operations we've taken so far, including the mathematical operation. It's always important to know the precedence, because if there is more than one operation in your statement, you need to know if you are which statement you are evaluating first. For example, if you have a statement that has increment and the not, the reverse, and had also the equal. So according to this precedent table over here, you are going to first execute this one. So this is one first, and this one second. So this one will go second, and this one will go last. If you have more than one operand that are in the same level, like ضرب القسمة وباقي القسمة, the mode over here, so all of them are the same precedence, same level, then you are going to evaluate the expression from left to right. But if they are on different level over here, then you are going to follow the precedence of these. If you have an expression that has, let's say, this one, and this one, and this one. These, you have an expression with all of these operators over here. Then according to the precedence table, you are first going to do this one, and then you are going to do the and, which is this one, and then the assignment operator, which is this one. So always pay attention to the precedence and associativity of the operands you have learned so far. So this is the end of this module. This module is included also in the midterm exam, so make sure that you understand every bit of it. If you have any question, you can always reach or ask. You can also ask about module 1 and module 2. This module you have been taught before I start teaching with you. Okay, so have a great day, and thank